Good afternoon. Our energy systems are not smart enough. As you've already heard all too often this week, our present energy systems, our human energy systems, are failing us. Nearly 2 billion of us, a quarter of humanity, still do not have electric light. Those of us who do are worried about keeping the lights on. What politicians call energy security is now a pressing issue even in the richest countries. The best available scientific evidence now indicates, as we've been hearing, ever more urgently, that the way we use energy is upsetting the climate of the only planet we have. If our future energy systems don't do better than this, we are in deep trouble. However, let's be clear about this and more precise. Despite all you hear to the contrary, the problems we face with security and climate are not about energy. They are quite specifically about fuel. We've almost forgotten the word fuel. We now say energy when we really mean oil or coal or natural gas or even electricity. They're not the same. They're not interchangeable. Smearing them all together like this is misleading and dangerous. The differences are essential. Indeed, the difference between fuel and electricity is one of the keys to a sustainable energy future, as I hope to show you. But first, let's clarify what we're talking about. Politicians around the world declaiming about energy security could mean secure, that is, reliable and affordable, provision of what we really want. Energy services such as comfort, illumination, motive power, mobility, and so on. But they don't. They mean secure provision of fuel, particularly oil and natural gas, and more particularly imported oil and natural gas. Why is this an issue? It is because all over the planet we already have a vast array of user technology, buildings and their contents, industrial plant, vehicles, and so on, that use fuel to deliver the services we desire. Interrupting fuel supply may interrupt essential services. That makes politicians jumpy. But fuel is only part of the story. Oil by itself is almost useless. Natural gas by itself is downright dangerous. Once you get beyond the bonfire, fuel is useful only because of the user technology that actually delivers the service. Yet we mostly take user technology for granted. Instead, we focus only on the fuel passing through it, as though the user technology were irrelevant for policy and decision making. We need to change our approach. We should be thinking not of fuel alone, but of systems. An energy system does not stop at the filler cap or the wall socket. Once we recognize that, we notice something profoundly important. Recent energy policy has laid great stress on competition as the way to optimize our energy systems. What policymakers mean by competition is that different suppliers of fuel or electricity compete for our custom. Within our energy systems, however, much the most important competition is between fuel and user technology. The better the user technology, the less fuel it needs to provide the service we actually desire. Fuel and user technology compete directly with each other. Key competitors for ExxonMobil are not Shell or BP, but Toyota and Volkswagen. Competitors for Gazprom may be the manufacturers and installers of thermal insulation. Competitors for E.ON and RVA may be the suppliers of compact fluorescent and LED lamps and so on. Within our energy systems, our dependence on fuel is the reason for our concern about supply security and for the mounting alarm about disrupting the climate. The obvious rational response must be to reduce our dependence on fuel. That means, first of all, shifting the balance within our energy systems away from fuel toward better user technology. We know how. We've known how for decades, especially for the most important energy technology of all, which is buildings. Government and policymakers have long given lip service to what they call energy efficiency. Then, however, they turn to what they're really interested in, which is supplying more fuel and electricity. That's understandable. Our suppliers of fuel and electricity earn their revenue by selling us their products. The more we have to buy, the more they earn. The way we have organized our systems means that fuel and electricity suppliers benefit from us living in poorly insulated buildings, using inefficient lamps and motors, and driving inefficient vehicles. From a system point of view, this is a cockeyed arrangement. When Thomas Edison set up his first central station electricity system in Lower Manhattan in 1882, he charged his customers according to how many lamps they used. He was selling illumination, the service they actually wanted. He had to optimize the whole system to keep the cost of illumination tolerable. Then, in the mid-1880s, came the electricity meter. Suddenly, Edison and his competitors were no longer selling illumination. They were selling electricity by the unit. Suddenly, they no longer wanted to optimize the whole system. They were happy to have customers use inefficient lamps and motors. Today's electricity suppliers still are, however much they protest to the contrary. The companies doing very well out of today's cockeyed arrangement will continue to resist any significant change because it is against their interest, unless we change the ground rules. We need to rethink the system framework for business and finance to remove this perverse incentive to inefficiency and poor system performance. What we now call energy companies should once again want to optimize our entire energy systems to deliver services as reliably and affordably as possible, and to make money doing it. That will mean investing everywhere on the system, not only in the fuel and electricity production facilities, but also in user technology and infrastructure, where we have the most headroom for improvement. The first strand in reducing our dependence on fuel ought to be upgrading existing buildings and other user technology, the top priority for real energy policy around the world. The second strand is electricity. While we are improving the performance of user technology, we shall still require either fuel or electricity to run it. This is where electricity will make the difference. We use two kinds of electricity. One kind we generate using fuel, such as coal, oil, natural gas, or uranium. The other kind we generate by harvesting natural ambient energy flows and turning them into electricity, including hydroelectricity, wind power, solar thermal power, solar photovoltaic power, geothermal power, and marine power. Most people call this renewable. I prefer to call it infrastructure electricity. This electricity does not use fuel. You invest in a physical asset, perhaps a wind turbine or a photovoltaic array. Once in place, a piece of infrastructure, it delivers electricity for you to use as you please. The implication is obvious. Of all the ways we use fuel, generating electricity is the easiest to change. Indeed, it's already changing at a breakneck pace. To reduce our dependence on fuel, as well as upgrading user technology to reduce the waste, we should also be aiming to move as swiftly as possible away from fuel-based electricity to infrastructure electricity. If we were starting now to electrify global society with what we now know about technology, finance, institutions, and environment, and about popular expectations, our electricity systems would look unrecognizably different from the systems that keep our lights on today. They are long overdue for dramatic change, and the change is indeed underway. We now know that we can generate electricity in much smaller, cleaner units, much closer to users. We can control system behavior continuously and automatically, with loads and generators both participating in real-time dynamic interaction, stabilizing the system autonomously. We can establish integrated, optimized local systems, including both generation and loads. Moreover, generating much of our electricity locally means that we shall be much more careful with it, ensuring that we use it in high-performance loads, especially buildings and other user technology. Decentralized local systems, in turn, can be coupled with much less need for long high-voltage transmission. And we can upgrade long lines to high-voltage direct current, doubling and even tripling the carrying capacity on the same conductors and way leaves. We already have the technology, both to upgrade user performance and to move to infrastructure electricity. Further technological innovation will help, but it's not critical. The critical innovation we really need is about finances, institutions, and social behavior. Both upgrading user technology and installing infrastructure electricity generation require a distinctively different framework for finance and business. What happens when you reduce the use of fuel by upgrading user technology and installing infrastructure electricity generation? In each case, what is entailed may be a substantial initial investment, after which the subsequent running cost is modest to minimal. But if the cost of fuel goes down, you have already tied up substantial capital in your initial investment. You do not have the option of reducing running costs because it's already minimum. Staying comfortable in your building costs more than it would with a flimsy building and cheap fuel. Similarly, generating your infrastructure electricity also means capital carrying charges you can't reduce, but make your electricity more expensive than someone else's electricity based on cheap fuel. Moreover, your electricity output will depend on the vagaries of natural ambient energy flows. The wind may not blow, or cloud may cover the sun. Reducing the use of fuel in our energy systems therefore removes flexibility and complicates risk management. If our future energy systems are to use less fuel, as they must, they will therefore require a different financial framework, different ways to provide flexibility and to manage risk, both for users and for providers of energy services. Let me give you a striking example. At least one global insurance company is now offering weather insurance, not only against hurricane, but also against a flat calm. Every individual wind farm operator is at the mercy of the weather. A flat calm means no generation and no revenue. But the insurer can build a portfolio of insured wind farms to spread the risk, allowing each farm operator a guaranteed minimum income, whatever the weather. Such financial and business innovation has enormous potential for future energy systems. We're beginning to see hints of what's needed. In the UK, for instance, we are just launching the Green Deal. In the US, they have so-called Property Assessed Clean Energy, or PACE, bonds. Companies are invited to invest to upgrade customers' premises and to earn a guaranteed return on the investment through a surcharge on fuel or electricity bills or on local rate bills. The upgrade, however, reduces the bill. Customer and company both benefit. The investment, moreover, is tied not to the customer, but to the premises. Even if the premises change hands, the guaranteed return on investment continues. It ought to be an attractive business proposition. We shall see. Meanwhile, of course, powerful interests, not just corporations, but entire countries, are doing very well out of our present fuel-based energy systems and the traditional arrangements that support them. At the moment, quite understandably, they have little desire to see these arrangements change. Indeed, some have been exerting significant and largely successful efforts to thwart any change. That places the onus squarely on our governments. If they accept that our present energy systems are failing us, governments have the power and the responsibility to make the requisite changes. However, I suggest that the most potent leverage available to governments may not be through legislation nor through regulation. As well as being legislators and regulators, governments at every level, national governments, provincial and state governments, municipal and city governments, are major energy users. They themselves can redirect energy investment and redefine energy business and take the energy companies with them. In their role as energy users, they themselves can change not only the discourse, but the practice. As clients and contractors, they can change the ground rules for the business of energy. They can launch and publicize, not just at the outset, but on a continuing basis as public education, major long-term strategic programs to upgrade their own buildings, fittings and other user technology, and to add innovative decentralized supply technologies for their own sites, including heat pumps, gas-fired microcogen, and infrastructure electricity generation. The contracts entailed would prime the pumps for the new breed of energy service company we need, persuading the major energy players to create effective and profitable energy service companies to bid for and to carry out the work. Such programs would create skilled jobs all over the country, bring down the unit cost of innovative materials and technologies, and provide vivid, practical examples to the private sector. Best of all, if properly organized and managed, they would save us taxpayers money. In the aftermath of the global financial mess, we've heard repeatedly about green stimuli and a green economy. The opportunity is obvious. Governments should stop telling the rest of us what to do and start showing us. Imagine what such programs could achieve worldwide. I concede immediately that I don't expect to be around to see us get very far along in this process. The obstacles are all too obvious and obtrusive. The traditional mindset, the way we think about electricity and energy in society, is built into our institutions and our social organization, our decisions and governance, individually and collectively. Governments, regulators, and corporate planners see their roles in energy in particular ways. So do energy users. That will not be easy to change. We may encounter physical constraints of resource availability, not for commodity fuels, but for infrastructure materials, including rare metals and other minerals of critical importance for high-performance technology and controls. The change I'm suggesting, away from fuels and toward infrastructure electricity, will create global constituencies of winners and losers, and the losers will not go quietly. Somehow, I can't see the oil companies, the coal companies, or the OPEC countries taking kindly to a low-fuel future. If the energy transition is to happen, and to happen in time, all the key players must see more opportunities than threats. That's why we have to change the ground rules, the business models, and the mindsets. Where is this transition heading? When assessing future energy systems, we need a vision. What do we think a future system ought to look like? How might it function? Not only technically, but financially and indeed socially. I can see, at least, the vague shape of a system that would make sense to me, what we might call a smart energy system. I hope I've outlined it sufficiently clearly for you to see it too. Of course, even if my outline of a smart energy system proves persuasive, We also have to devise a way to get there from here. But I'm ever more convinced that one key to a sustainable future for our only planet will be sustainable electricity and smart energy. Let's go for it. Thank you.
Can I ask a question before you go?
Of course, by all means. If anyone wants to ask them, sorry, I should have said that if anybody has any questions, I'm happy to try to respond.
Thank you. I think that's understood. I can readily understand, of course, that providers of fuels are happiest when their customers consume most fuel. But surely those who are responsible for the machines that turn that fuel into energy don't have that interest. In fact, for example, in the case of the motor car manufacturers, they're devoting a good deal of time and expenditure trying to see that the cars they build do not consume so much fuel. Is that not the same in other areas of consumption, such as the provision of electric lights and so on, and Philips and so on? So at the present moment, those who are actually making the consuming machinery have a motive in keeping it to the minimum required fuel. How much more can we add by blending them with the providers of fuel?
I think the important thing to recognize is that the manufacturers of user technology of various kinds, including buildings and cars and appliances and so on, are first and foremost, as you say, interested in selling more of their output. And in the case of buildings, for instance, they can keep the costs down and persuade people to buy them much more readily by making very flimsy buildings. Because that means that the customer will then, even the UK government has this problem of talking about so-called affordable housing. What they mean is the ticket price. The ticket price is low. The difficulty is that if you keep the ticket price low by leaving out the insulation and using flimsy wood doors and windows and so on, then the poor owner, the person who purchases this at a low initial price, then has a very, very high long-term running cost, because you have to use so much fuel and electricity to keep the building habitable, never mind comfortable. And that is a problem that we've been stuck with, particularly in the UK, for a long time. Very, very bad buildings. The argument is not so strong in the case of appliances or indeed of cars, because you do not save that much money by cutting down the efficiency of a car engine. So in fact, car manufacturers can and do try to make their cars more efficient both by making them lighter, making them more aerodynamically designed, by doing all the kinds of things that you can do to keep the actual performance of the vehicle high while keeping the cost moderate. And the same is true for what are called white goods, like refrigerators and freezers and things of that kind. You can make them very much more efficient with very, very minimal additional cost. In some cases, the cost is actually reduced. The same, oddly enough, is true with buildings, that if you design a building properly, the building fabric itself does a lot of the work of keeping the building comfortable by maintaining the temperature at the right speed, at the right range, and by allowing for natural convection of air and natural circulation of light and natural access of light and so on. So that you may have to spend more on the insulation, but what you spend on the insulation is actually saved by being able to have much smaller heating and ventilating systems in the building, maybe not even requiring them at all. So there are trade-offs that actually work to our advantage in this if we are willing to take them. So it's not a black-white issue in any case. It does require that you take each case on its own merits, but there are strong arguments in favor of getting the user technology right and to the advantage of the people who manufacture it. I absolutely agree. Thank you.
Thank you for that, Walt. It's most interesting. The thing that worries me is that the UK government hasn't been investing very much in renewables. I mean, as part of our energy mix, it's less than 4%, which is the worst in Europe, apart from Malta, whereas Germany's over 20% and Sweden's over 40%. So we're not doing very well. But what the government is doing is it's giving feed-in tariffs, and they vary as to which renewable it is supporting. So they're sort of picking winners that they think are going to be the important renewable energy source in the future. What do you think about that differential pricing of the renewable sector?
I haven't given the matter much thought. I think there's a case to be made, and the government would make it, for suggesting that the level of support needed by different infrastructure electricity technologies depends to a degree on the maturity of the technology. So that, for example, wind technology is now pretty much mature, although it's still innovating quite rapidly, but it is already able to generate at a price, if you're doing it in terms of price per unit of electricity, at a price which is broadly comparable with the price that you're able to get from gas-fired combined cycle.
But the highest feed-in tariff is offshore wind at the moment.
That is because at the moment it is a technology that is a long way from mature. There's an awful lot of work still to be done on it. And it has historically always been the case that if a government thinks that a technology is likely to be of value in the future, it will provide what you might call startup support to get the technology off the ground through what the technology people call the valley of death, between the initial prototypes and the eventual commercial full-scale manifestations of the technology.
Why support offshore wind when it's clearly more expensive and much less efficient and has far greater problems than having onshore wind?
Well, you're making a lot of assumptions there, which I think some people would dispute. It is expensive now because it has not yet been developed very far. I think it has enormous potential. The resource is huge. It does not raise the problems that are raised by putting wind turbines on land, to which some people object. I personally think wind turbines are beautiful, but I'm not by any means in the majority in that respect. I think if you write off the potential of a technology before you have given it much of an opportunity, you're likely to be losing something that could be valuable. And I'm perfectly happy to see them continue to support offshore wind because of its enormous potential, because the resource, as I say, is huge. And it is all over the world as well. So if we actually manage to get it right in the UK, it might even turn out to be a pretty good export business for us.
But that's true of all renewables. I mean,
no, it's not.
Geothermal has got huge potential. They don't fund that. You know, there is an argument for saying that you promote renewables equally and you let the market decide which is the cheapest and most effective. You shouldn't.
Yes, there's an argument. I don't agree with it, but there's an argument.
The government should not be backing winners in the renewable sector. They ought to let the business community decide which the best renewable is.
If the business community had its way, the business community would be dominated by the fuel interests, and none of the renewables would get a look in. And the fuel interests, as it happens, get very much more financial support than the renewables do, in terms of tax relief and various other business finance arrangements which are not available to renewables. So I think there's a discrepancy there which is invidious to the renewables rather than the other way around.
Thank you.
Okay?